All right, good morning, everybody. Today we're going to talk about the second half of Chapter 1, Section 7, and that has to do with evaluating functions. So this can be a little bit tricky sometimes. Hopefully you all catch on easily, but depending on what we're evaluating and what is being put into the functions, it can be a little tricky. So um, as always, if you run into any questions, you feel free to email me at my mccallS@shaler.us. So, all right, let's get started. So, first, we're going to talk a little bit about vocabulary. It says equations that are functions can be written in, and the word is function notation. And so, this word right here, function notation, it sounds a little scary and it looks hard, but it's really not. What I want you to notice is normally when you would write equations right here, if you look at y equals 3x minus 8, you would have a variable y right there. The only thing that they're going to do is replace that y with f of x. That is pronounced f of f of x. And the reason why they do that is the function notation is a better way to write equations so we know what we're plugging into the equation. And you'll see as we move on how that works. So this first example here, it says function values. It says for f of x equals 2x minus 3, find each value. So right here, for f of x equals 2x minus 3, find each value. So what they're asking us to do in this first equation right here, this f of 5, is they're saying take the function that we have that I just underlined, and in place of x, they want you to put 5. So this is the reason why we use function notation as you move into higher level math, is it's more descriptive. It tells us what value we're plugging into our function. So I'm going to take my function f of x equals 2x minus 5, and I'm going to plug in the value 5 for that. So when I do that, f of 5 is equal to 2, and you can see that's where the x is. Notice when I put parentheses where the x value is. I want to see you do this on your work. You have to do this on your work. And then inside your x, you're going to put the number 5. And so right there, we have 2x minus 3, and you can see I substituted the value 5 in for x. And then from there, we're going to follow PEMDAS and simplify it. So multiplication comes first, so it becomes 10 minus 3, which is 7. And so now what we can see is when you plug the number 5 in, you get the number 7 out. You could also write that as an ordered pair, 5, 7, because that represents inputs and outputs. So let's look at the next one. Look at part B. We want to do f of 1. So I'm going to take my function again, f of 1, and we're going to take 2 in place of x. I'm going to put a set of parentheses, minus 3. And then inside that parentheses, I'm going to put a 1 right there. Okay. And from there, I'm going to follow PEMDAS. 2 times 1 is 2. And then 2 minus 3 is negative 1. All right, let's look at part C. Part C, all of these are pretty much done the same. Part C, we're going to substitute the value negative 2 in. So again, we take our function, 2, and then x minus 3. And in place of that x, I'm going to put in the number negative 2. And then we're going to follow PEMDAS and simplify it. 2 times negative 2 is negative 4. And then negative 4 minus 3 is negative 7. And there's the value for that. So as you guys can see, as we're substituting values in, we put an input in, and then we get an output out. And that's what a function is. Now, I'm not going to do all of those because I think the first 3 you should hopefully have gotten an idea of what to do. Now, I am going to do a couple of these because these are a little bit tricky than the last one. So this is another function. This function's a little more complicated than the last function, though. If you look at this function, it's f of x equals x squared minus 5x. And the thing that I want you to key in on this one is there are two different variables in this function. There are two x's. And so what that means in the first problem, in part G, they ask us to substitute the value 2 in. You can see the value 2 right there. That 2 has to go in to both of the x values. So let me show you how to do that. So the new function f of x is x squared minus 5x. So you're going to see I'm going to write this out with parentheses first, x squared minus 5x. But instead of where the x's were, I put a set of parentheses. Now it's telling us that we're going to substitute 2 in. So we're going to put the value 2 inside the parentheses like that. And then from there, we've got to follow PEMDAS to simplify. And so PEMDAS says parentheses followed by exponents. So that's what we're going to do first. 2 to the second is 4 minus 5 times 2. Next, we're going to do multiplication. 5 times 2 is 10. And lastly, 4 minus 10 is negative 6. Okay, let's do another one of those because those are a little trickier than the last one, just a little bit. Okay, so we have f of negative 3. So I'm going to write my equation out first. So it's x squared minus 5x. And inside the parentheses, in this case, we're going to put in negative 3, but it has to go in both places where there was a variable. And then from there, you are going to square first. So negative 3 times negative 3 is positive 9. And then minus 5 times negative 3. Followed by that, we are either going to do subtraction or multiplication. PEMDAS says multiplication. So we have to do negative 5 times negative 3, which becomes positive 15. And then 9 plus 15 is 24. And there's your final answer for part H. Moving on to I, same thing as the last one. So we're going to write our equation, x squared minus 5 and then x. We're going to substitute in the value, negative 4, negative 4. And from there, we're going to follow PEMDAS, which we're going to do exponents first. So negative 4 times negative 4 is positive 16, minus 5 times negative 4. And then we're going to do multiplication, 16 plus 20. And 16 plus 20 is 36. Okay, so the last one for the day, same thing. We're still using the same equation, the same function from above, the x squared minus 5x. So this is equal to x squared minus 5x. And we're going to substitute 6 in. Everywhere where there was a variable, 6 and 6 goes right there. And then we're going to follow PEMDAS. 6 squared is 36, minus 5 times 6. 36 minus 30 is 6. And there's our final answer for that one. And as I did before in the other question, you can always write these as ordered pairs once you get your answer. It didn't ask you to do that, but you can notice that we plugged in 2 in the equation in this first one, and we got negative 6 out. So the ordered pair would be 2, negative 6 for that one. In the second one, we plugged in negative 3, and we got 24 out. So there's your input and your output. In the third one, we plugged in negative 4, and we got 36 out. And then the last one, we plugged in 6, and we ended up getting 6 out. So there you go. So hopefully that made sense to you guys. If you have any questions, feel free to email me. Have a good day.